Hello, YouTube. Let me tell you something interesting, and you will see that the world around us, as described, is definitely not what it seems. And all the ideas are being cast away, and new knowledge is coming in. But let me start with the year 1983. Modified Newtonian dynamics, or MOND, is a hypothesis that proposes a modification of Newton's law of universal gravitation to account for observed properties of galaxies. It is an alternative to the hypothesis of dark matter in terms of explaining why galaxies do not appear to obey the currently understood laws of physics. Created in 1982 and first published in 1983 by Israeli physicist Mordechai Milgrom, the hypothesis' original motivation was to explain why the velocities of stars and galaxies were observed to be larger than expected based on Newtonian mechanics. MOND departs from Newton's laws at extremely small accelerations that are characteristic of the outer regions of galaxies, as well as the intergalaxy forces within galaxy clusters, but which are far below anything encountered in the solar system or on Earth. Let's travel in time to the year 2023. Physicists have made a crucial discovery of historical proportion. Einstein's laws are not accurate, and the invention of a time machine is just around the corner. Professor Kun-Hyun Che supplemented Einstein's laws by proving the existence of modified gravity. So, according to some people, this is how the 21st century really begins in terms of importance. A truly fundamental discovery has been made that turns the foundations of physics upside down. First there was Newton, then Einstein, and now the Korean scientist Kun-Hyun Che stands in a row with them. He discovered that both classical physics and the theory of relativity are powerless in weak gravitational fields, and also there is no dark matter. Well, you can relax and stop looking for dark matter. But is it possible to believe these conclusions? Let's take a look. See, the work of the Korean researcher has been published in the authoritative The Astrophysical Journal. That is, it passed all possible checks and does not contain the slightest inaccuracy. Well, there are few scientific publications in the world that can be trusted unconditionally. If we're talking about astronomy, then you can trust just this magazine, according to Russian scientists. I'm sure others would support them as well. Let me briefly remind you of the background. When Newton published his theory in 1687, it worked perfectly. In 1846, based on its theoretical calculations, Neptune was discovered, so the triumph was complete. Soon, however, it became clear that Mercury's orbit does not obey Newton. The study of Mercury eventually gave Einstein's theory of relativity and new physics in general. Mercury is close to the Sun, and with such a strong gravity, Newton's laws were a mistake. Already in the 20th century, studying galaxies, they found that the galaxies move not like Newton's and even like Einstein's. To save both theories, dark matter was invented. It does not interact with ours in any way and it cannot be detected, but it attracts. Actually, physicists are afraid of the fact that it is impossible to detect, but it exists. If ufologists or psychics, for example, would say this, they would immediately be accused of pseudoscience. But scientists believed in dark matter, but not all of them, of course, and began to search intensively for it. Meanwhile, the Gaia satellite has been rotating in orbit since the year 2013, and doing inconspicuous work. It measures distances to stars and generally stellar positions. It's a complete routine. The data really doesn't get into mass media because it's widely boring to most people, but not to the astronomer from Seoul, Kyun-Hoon Che. He was not afraid and asked the satellite for information about the orbits of binary stars. In general, the fact that the sun is lonely is rather rare. Usually the stars are double, triple, and more. The Korean scientist was interested in the orbits of relatively close binary systems, up to 650 light years. Such data is more accurate. And in total, he analyzed 26,500 binary systems. And what did he find? Imagine that one star revolves around another. The forces of gravity do not allow it to fly away. But are they great? Very, very weak, vanishing. The sun attracts Pluto much more strongly than the main star would attract its satellite. It turned out that when gravity is so seriously weakened, it increases. It's very strange. Here you are flying away from the sun, it loosens its grip, then you're almost not holding on to its gravity, and suddenly the sun seems to squeeze its clothes, so to say, and you're again in captivity. The sun says, oh no, you are not going to leave. It is for this reason that binary star systems do not fly apart. And we were wondering why this was happening. In science, the reliability of discovery is evaluated by the so-called sigma. The Korean scientist has a level of 5 sigma, and for most conclusions even more. That means that his calculations are correct with a probability of over 99%. Well, that shows you, and since August 16 of the year 2023, the discovery was published on that day, we know that there are now 3 theories of gravity. Newton, for everyday life, for example, Newton's physics, perfectly explains how stones fall and cars drive on the planet Earth. Einstein, for high speeds and powerful fields. If you have launched a satellite, you already need to take into the account the theory of relativity. GPS systems do this automatically. If it weren't for an Einstein, navigators would not be able to work. Kyun-Hoon Che, for very weak fields. It's interesting, but 40 years ago, the theorist Mordechai Milgrom predicted all this and formulated the modified theory of gravity, but few people paid attention to it. So, on Wednesday, August 16, in New Physics, Hyun Che Milgrom, or Hyun Che-Milgrom, was born. Milgrom has already commented on the event in the spirit that it looks like a revolution in physics is happening right now. Neither dark matter nor dark energy are needed now. Billions of dollars have been wasted on their research. The universe does not need some kind of agent that acts and bends. The laws of nature themselves are flexible. In the same way, more than a century ago, the ether was discarded, in which everyone believed, as well as they do in the dark matter. Einstein finished off ether, Hyun Che finished off dark matter. So what will happen now? Time travel? An instant visit to anywhere in the universe? Now you can talk about it and not be considered a science fiction writer. Gravity seems to be a very understandable thing. I'm sitting on a chair because it's gravity, and yet it is the most mysterious force, and not strength at all. Einstein proved that gravity is a curvature of space-time, that is the floor on which everything in the universe walks. You and I, planets and galaxies. In the 20th century, quantum gravity appeared, which proves that there is no space and time as such. There is only gravitational field that creates for the observer, for us, the illusion of here and now. But they could not detect a particle of gravity, a graviton, or graviton, which transfers gravity from me to the Earth, from the Earth to the Moon, and so on. Now they will find everything. They will learn to control gravity and time. We lacked something for this decisive step. Now this something has appeared. Gravity appeared before us in all its manifestations. Theorists will have to understand how all this works exactly. Experimenters will have to confirm it. Engineers will have to make devices for the home, for the family. A new era has begun. Now, this was from Russia. People who are covering physics, they presented it. But I want to tell you something now from Korea. The Sejong University Department of Physics and Astronomy, Professor Kyu-Hyun Cha, obtained conclusive evidence that Newtonian mechanics collapse in the orbital motion of long-period binary stars. The results of this study are direct evidence that Newtonian mechanics collapses when gravity weakens, and it means that not only Newtonian mechanics, which has been around for 300 years, but also general relativity, which has been going on for about 100 years, must be revised. It means that the Big Bang cosmology based on general relativity must also be revised, and it means that the large amount of dark matter required by Newtonian mechanics and general relativity is no longer needed in the universe. And Sejong University announced the results of this research. Announced that the results of this research were published online on the 24th in the Astrophysical Journal published by the American Astronomical Society. A paper title was Breakdown of the Newton-Einstein Standard Gravity at Low Acceleration in Internal Dynamics of White Binary Stars. Professor Cha, with the help of Dr. Karim El-Badri of Harvard University in the United States, used the latest data from the European Space Agency's Gaia Space Telescope on about 26,500 long-period binaries within 650 light-years. This is the largest and most detailed data available on binary stars. To test the properties of gravity, Professor Chaya calculated the acceleration experienced by the binary according to the distance between two stars, that is, the size of the orbit, and compare it to the predictions of Newtonian mechanics. The larger the orbit, the longer the orbital period, and the weaker the gravitational acceleration. Thus, it is possible to reveal how the properties of gravity change when the acceleration weakens. As a result of the analysis, a surprising result was obtained that collapsed Newton's law of universal gravitation. Attempts to test gravity with long-period binaries have been made several times over the past decade, but no conclusive results have been obtained. Professor Chaya noted that gravity is acceleration and developed a new Python code that accurately calculates the acceleration experienced by a binary star, and this code was able to obtain the result. The reason why long-period binaries are important for gravity testing is that they have never been directly detected, unlike tests by galactic or cosmological data. But gravity can be tested regardless of the assumed dark matter concept. Commenting on this discovery and future prospects, Milgrom said, "These results are the result of a very careful analysis of state-of-the-art data. The ramifications of this outcome are very, very real. Therefore, independent validation in the future, preferably with new and improved data, is important." So, in the future, in the future, if this discovery is verified and in particular confirmed to match Mann's predictions, it will have an immeasurable impact on astrophysics, fundamental physics, and cosmology in general. Professor Chai understands that it will not be easy for the world to accept this result as he did just a few years ago. We will continue testing gravity through long-period binaries and other data. We will do so until it is solidified as a general scientific fact, such as the acceleration of Earth gravity. Yes, this is a very interesting new world, and I suggest you keep an eye on further research by Professor Chow. Very, very interesting. So this is what I wanted to let you know today. And if you like my channel and my research, please support me through the links you will find in the description to this channel. And please like my videos, and I'll bring you more interesting information. Thank you.